So let's look at an example of a data set and calculate the correlation coefficient of this data set. So here is a table of numbers, x and y, and we can then apply the formula that we wrote down on the previous slide to calculate that. Let me rewrite it so we have it here for reference. So we've got r is equal to this really long thing. So I'm going to shorthand the sum. I'm just going to write sum of x minus mean x times y minus mean y. And then we have the square roots on the bottom, which was the sum of x minus the mean value squared times the square root of the sum of y minus the mean value squared. So that's our r. And we want to calculate these individual things. And so I'm just going to write down the numbers, but we can calculate the individual pieces, and you can check this. And we'll actually go to some online exercises where we can use some online tools to do this calculation for us, which will make life a lot easier. So let's at least write down that we've got the mean value of x. I can write that as I have 10 points. And so that's 10 points over the sum of all the different values. And so that comes out to be 5.3. And the mean value of y, again, I have 10 points, the sum over the y values, and that comes out to be 5.6. And then I can compute, now that I know the two means, I can sum over all of the different points and write down this product here that we need. So the sum over all these points of x minus the mean times, x, times y minus the mean. If I do this computation using this data set, so for each of these, I go to the table, each row of the table, and I take x minus the mean value of x, and I multiply that for that pair times y minus the mean value of y. So for the top one of these, I'm going to get something like minus 4.3 times minus 4.6 here. That's going to be one term in the sum. Then I'm going to compute that for every row of the table and add them all up. So if I do that, I get 90.2 as this sum. And then I need the last two ingredients, which is the sum of, for each row in the table, the value of x minus the mean value quantity squared, and the value of y minus the mean value quantity squared. And so I can compute those as well. So the sum of x minus mean x squared is equal to 96.1. And the sum of y minus mean y squared is going to be equal to 154.4. So those are all the ingredients now. This is my numerator, and these are the two pieces of the denominator squared. So I have to take the square roots of these and then divide the numerator by that. And so if I do that for this data set, I get that r is equal to 0.74. So r should be close to 1 if these things are linearly correlated. And so we can see that, for this data set, it kind of looks like there's a linear relationship. It could be linear. It's not perfect. And so for this data set, then, we would expect to get a correlation coefficient that's non-zero, and it's sort of close to 1 since this is a positive slope. And so that makes sense. And these are the values you get by looking at this data set. So now we've just gone through this whole computation, and I'll show you next how to do this automatically using some online tools.